Hello students, today in this video once again we'll go through a very important topic from module 2, corrosion and metal finishing. So far in the previous video we understood some of the topics from corrosion, where we understood starting from the idea or introduction about corrosion, what exactly it is, or how exactly it takes place, electrochemical theory of corrosion. Then we understood some of the types of corrosion, then factors affecting the rate of corrosion. Now from corrosion we'll move on towards the last topics, that is corrosion control. So according to your syllabus, three important way of corrosion control you have to study, that is anodizing is the first one. Then you have to study cathodic protection method. Then you have to study the metal coating method. Only three methods you have to study according to your syllabus. Otherwise corrosion can be completely avoided only under ideal condition, which is not possible, since it is impossible to attain such condition. It can be minimized by using various corrosion control methods. They are by giving protective coatings, by using corrosion inhibitors, by cathodic protection methods. Basically corrosion control is character divided into two types: inorganic coating, organic coating. In inorganic coating we have metal coating, cathodic protection, surface conversion coating. Once again, metallic coating, there is two types: galvanizing and tinning. You have to study galvanizing process, which comes under metallic coating. Then under cathodic protection we have sacrificial anodic method and impressed current method, both of which you have to study under cathodic protection. Then surface conversion coating, you have anodizing and phosphating, out of which you have to study anodizing. That means you have to study anodizing, galvanizing, sacrificial anodic method, impressed current method. These four methods you have to study. So today in this video, after inorganic coating we have organic coating, which could be giving a layer of coating the surface of the metal with paints, enamels, such. Okay, so now first method, that is anodizing, will start or we'll understand in today's video. So anodizing, particularly you have to study anodizing of aluminium. So we'll just see what exactly it is. Now anodizing, name itself indicates anode comes here. I hope so far it is clear to you that in any electrochemical process or electrolysis process, there will be anode, there will be cathode, and there will be an electrolyte. So here anode, anodizing is nothing but making anything anode. So hence the name anodizing. Process given on anodes is called as anodizing in simple words. Okay, so now what is the definition? The process of formation of a film of metal oxide on the surface of a metal by electrochemical oxidation is known as anodizing. So students, we already now know that the corrosion is a surface phenomena. Only on the surface of the metal article this corrosion takes place. Only when the corrosion takes place, reaches to its severe level, then the entire article gets corroded or destroyed, but it starts from the surface. So but in protection, in the way of protection of that metal article, first step is to protect the surface. If by any means we are protecting the surface of the metal, then there will not be any question of corrosion, or we are we can minimize the rate of corrosion if we are protecting the surface. Now what is done here? Whatever metal article is there, its surface is converted into oxide film. In this particular anodizing process, oxide In phosphating, it is converted into phosphate, metal phosphate. Here metal oxide, for example, if you have a metal, its surface atoms are converted into their compounds, their oxides. So what happens, we already know that, students. So during the extraction process, metal from its original states, it could be oxide, it could be any hydroxide, chloride, any form of its ore is converted into metal which is unstable, hence it undergoes corrosion. This we understood in the very first video of corrosion. So if by any means we are converting the surface into its original state, that is its oxide state, there will not be any question of corrosion or less corrosion takes place. So in the similar way, how to achieve that? By using the process known as anodizing. What is done here? The outer surface is converted into oxide. Only, students, remember here, only the outer surface is converted into its oxide. In this particular case, it is converted into its oxide, metal oxide, but the inside it will be the same metal. So by this means we can protect the surface of the metal. So anodizing is an electrochemical process that converts the metal surface into a decorative, durable, corrosion resistance anodic oxide finish. So here it could be for anything, for decorative purpose, it could be for increasing its property, durability, it could be for corrosion resistance, anything. So it is a electrochemical process. Now particularly we'll go to anodizing of aluminium. Anodizing of aluminium is the process of formation of a film of aluminium oxide Al2O3 on the surface of aluminium metal by electrochemical oxidation. So particularly what is formed here? Aluminium metal article, when it is introduced to anodizing of aluminium process, that aluminium surface is converted into aluminium oxide. Earlier it was only Al, aluminium. Ultimately at the end it will be converted into Al2O3, only surface here, students, remember. So that what happens, that Al2O3 is now corrosion resistant, it will not affected by the further attack of oxygen, of water molecule, etc. So in this way it will be converted. So now clear idea what is the exact setup here. In a container, the electrolyte is taken, or plating bath we are calling it as taken, and here particularly the article to be anodized is made as anode. So positive terminal anode is nothing but aluminium component. So aluminium metal component is made as the positive terminal or anode. So hence the name anodizing. Then any other metal is made as cathode. So particularly in this process, steel or carbon electrode is made as cathode. So there will be anode and there will be cathode and there will be electrolyte. So hence it is an electrolysis process. Then after the process, the anode, which is aluminium component anode, is converted into anodized surface. Al2O3 coating will be formed. So exact step-by-step process we'll study now. Okay, process of anodizing of aluminium. First, the aluminium article to be anodized is degreased, followed by electropolished to remove impurities present on the metal surface. Okay, now what do you mean by this degreasing, electropolishing? So now, as soon as we form any metal article, for example, if there is a what you can say, a key, aluminium key we have. So after when in the die we are pressing or whatever by any method, if suppose we form that key, then it will not be cleaned. It may have some grease on it, may have some dust on it, it may have some corrosion product on it, because we already know that as soon as a metal is obtained, there will be corrosion occurring. So now that must be removed before we employ it into the exact process. So degreasing is done. So usually in degreasing, what is done? The article is first dipped in acids, or organic solvents to remove the scale on it. Then electropolished. So once again it is introduced into electrolysis process where the rough surface is made as smooth. That process is called as electropolished. When any article is connected in an electrolysis process to remove the rough surfaces, it is called as electropolish. So this is nothing but preliminary steps. So in preliminary steps, the degreasing, electropolishing and all is done. Then it is connected to positive terminal. What is connected to positive terminal? The aluminium article to be converted into the surface of which is converted into aluminium oxide is connected to positive terminal and made as anode. Steel or copper is made as cathode. The anode and cathode are dipped in electrolyte solution containing 5 to 10% chromic acid, Cr2O3. Chromic acid is the electrolyte used. The temperature of the bath is maintained at 35 degrees Celsius. A current density of about 10 to 20 milliamps per centimeter square is applied. Voltage is applied between 0 to 50 volts. These are the experimental conditions. In the similar way, step by step, you need to write. First is your preliminary treatment where the article is decreased and electropolished. In the second step, what is done? It is connected to a positive terminal and made as anode. We have seen that in the diagram. Then another electrode, because we need to complete a cell. Another electrode, steel or copper, is made as cathode. Then what are the plating bath composition? It contains 5 to 10% chromic acid. Then temperature, we need to maintain the temperature of the process. It is 35 degrees Celsius. Then current density of about, we are passing electricity through it. So property such as voltage, current density must be maintained. So current density of about 10 to 20 milliamps per centimeter square is applied. Then voltage applied is 0 to 50 volts. Okay. For the first 10 minutes of the process, when we are starting the process, the potential is maintained at 0 to 40 volts. Then after 20 minutes, the voltage is applied from 40 to 50 volts. It is increased slowly. Then ultimately, the voltage is kept for about kept 50 volts for about it must be 5 minutes. So for 5 minutes. Then an aluminium oxide layer of 2 to 8 micrometer thick is obtained. For high thickness, 10% H2SO4 is used as electrolyte. Finally, the object is treated with nickel acetate or cobalt acetate followed by boiling water treatment to improve corrosion resistance. Now once we have formed an aluminum oxide layer, if you want furthermore thick layer, we can along with 5 to 10% chromic acid, we can use 10% H2SO4 also. Then finally the object is dipped in nickel acetate and cobalt acetate. Then it must be introduced into boiling water to improve the corrosion resistance property. This was the process. In the similar way, let us see what all are the reactions. The observed electrode reactions are: at anode, 2Al plus 3H2O will form Al2O3 plus 6H plus. 2Al plus 3H2O will form Al2O3 plus 6H plus 6 electrons. At cathode, 6H plus 6 electron will combine to form 3H2O. Net reaction, 2Al plus 3H2O will form Al2O3 plus 3H2. So here, what is the role of this chromic acid? It provides electrons. It provides electrons as well as it acts as a electrolyte. Here aluminium surface is converted into something else. It is nothing but the surface conversion coating. So this was the process Now, what are the application of this anodized article? And anodized articles are used for soap boxes, tiffin carriers, window frames, household utensils. Household utensils and all are anodized now for a corrosion resistance property. Otherwise, if only aluminium household utensils are there, you might have observed this, there will be corrosion product formed on it. Otherwise, after anodized will not it will possess corrosion resistance property. So student, this was anodizing of aluminium. In the next video we'll see the other corrosion control methods. So thank you.